The last video example and lesson in section 3.1, I'm going to talk again about solving word problems. And we've mentioned this already, that this is the majority of this class. So again, I'm going to help you with word problems, and hopefully we become a little bit more familiar and comfortable doing them. So if you want to pause the video and write down the one problem I'm going to do, this is example number 1, and I'll read it to you. Marco is draining his 2 aquariums, which are the same size. One tank has 7 inches of water and drains at 1 inch per minute. The other begins with 5 inches of water and drains at 0.5 inches per minute. After how many minutes will the tanks contain the same amount of water? Now, we're going to solve this by graphing, just like we did in the previous examples and lessons. But the first thing we need our equations. We have 2 situations, which I'm going to underline in red. One, and this is what you have to pick out of the problems, is just what's important mathematically. One tank has 7 inches of water and drains at 1 inch per minute. And then the other one begins with 5 inches of water and drains at half an inch per minute. Now, as we've talked about, when you're dealing with linear systems, we know linear systems are in the form y equals mx plus b. And so therefore there's a slope and a y-intercept. Now, let's pick out the key words. First of all, what I underlined in red, the magic word per. That tells you right away that 1 inch per minute is the slope. And if we remember, and probably the first thing we should do is figure out what our letters stand for, what x and y mean. And we know slope is y over x, and it just told you that the slope is inches per minute. Therefore, the y label has to be inches, and the x label has to stand for minutes. And so that is how we're going to label our graph and know what x and y stand for. Now, if we write the first equation, it says it begins, or it has 7 inches of water to begin with. So the first equation starts at 7 and it drains. Drains means goes down, which is minus, by 1 inch every minute, which is the letter x. 1 is our slope, and now we have our equation in the form y equals mx plus b, where the y-intercept is 7 and the slope, y-intercept 7 and the slope is negative 1. The second equation, which I'm going to write it in green, it says it begins at 5. And there's the magic word per. Per means slope, which is a half. So therefore, it starts at 5 and it goes down a half every minute, which is x. And of course, that's equal to y. And that is how you develop and write your 2 equations that will form our system. If you have further questions regarding that, please let me know. But otherwise, that's what you need to pick out of a word problem. You need to recognize that there are 2 situations. There's 2 things that are being compared here, and therefore you need 2 equations to solve the problem. Now, I rewrote the equations, and we're going to graph them. Well, they're already in slope-intercept form, which is nice. We know the slope of the first equation, or the tank empties at 1 inch per minute, so the slope is negative 1, and the y-intercept is equal to 7. And so I'm going to plot 7 on my graph up here, and it goes down 1 inch, negative 1 over 1, rise over run, down 1 inch every minute. And obviously, the tank is only going to drain until there is 0 water left in the tank. Now, we know that the x-axis, which I'm going to highlight here in green, the x-axis, these numbers are in minutes, so if you want to label it, you sure can. And the y-axis, which is in green, that is inches, or how many inches is left in the tank. Well, we can only be in quadrant 1. So therefore, my graph is going to stop right there when it gets to 0. So that is the graph of my first situation. We cannot go into quadrants 2, 3, or 4 because these deal with negative number. And you can't have negative minutes, you can't have negative inches. That doesn't make sense. Our second tank, the slope is negative 1/2, and the y-intercept is equal to 5. So I'm going to plot that information. My y-intercept is 5, and it drains at 1/2. So I go down 1 and over 2 and put a dot, down 1 over 2, put a dot, down 1 over 2, put a dot. And our graph goes something like this. I believe it's going to end up right here. So it looks like we have an intersection point. The intersection point, and I'm going to go back up here because the question says what we're supposed to answer is after how many minutes will the tanks contain the same amount of water? Now if I go forward again, there's our intersection point. The coordinates of that is 4, 3. So what does that tell us? If I write it as an ordered pair, this is x, and we know x stands for minutes, and this is y, and that is the amount inches. So therefore, the answer to the question is after 4 minutes, the tanks are equal in height, and that, how high are they? It's 3 inches. The water in both tanks is 3 inches. And that is how you interpret and answer a word problem with a graph and a system of equations. So hopefully that makes sense to you. 4 minutes is the answer, and if they ask you how much water does both tanks have, the answer would be 3 inches. So if you have any questions about that, please let me know. But I'm going to also show you this. This particular system of equations we could also solve without a graph. I'm going to rewrite the two equations. Now, the question is, when are they the same? Well, if they're the same, that means the two y values have to be equal. That y value and this y value are the same. Therefore, the two equations have to be equal. So I guess this problem is really asking you, when is 7 minus 1x equal to 5 minus half x? And anytime they ask you, when are they the same, or at what point are they the same, you can set the two equations equal to each other. Now, if I solve this, I'm going to add 1x to both sides, and I get 7 equals 5 plus half x. And then I'm going to minus 5 to both sides, and I get 2 equals half x. And I'm going to write that up over here because I ran out of room. 2 equals half x. And in order to solve this, we invert and multiply. So I'm going to invert that fraction and multiply. And that leaves us, these cancel out, and that leaves us x equal to 2 times 2, which is 4, which is the same answer we got by graphing. So after 4 minutes, these two tanks contain the same amount of water. And if I wanted to find out how much water that would be, I would just take 4 and plug it into one of the equations and find out. So that is how you solve a word problem, both using a graph or by setting the two equations equal to each other. And again, if you have further questions, let's discuss it in class and bring your questions to class.